Since inspection of welds using ultrasound is a leading-edge technique for finding in-weld flaws, it is important that those involved with welded fabrication have some knowledge of the method and its application. The basic ultrasonic equipment consists of a power source with CRT screen, probes, and calibration blocks. Ultrasonic waves are generated by applying electric current from the power source to a probe. The probe contains a piezoelectric crystal such as quartz. The piezoelectric effect allows conversion of electrical energy to mechanical energy. The mechanical energy is then transmitted through the material under test, and any energy that is reflected is returned to the probe, converts back to electrical energy, and is then transmitted to the ultrasonic equipment. To transmit the sound energy into the material, the air gap between probe and metal must be eliminated. This task is performed by using a couplant, usually oil, grease, or water. The calibrated CRT screen displays the history of the transmitted ultrasonic waves. Principally, these are the distance the sound travels, or time base, shown on the horizontal axis, and the amplitude of any reflector, given on the vertical axis. Prior to testing a weld or other component such as a casting, the equipment must be calibrated on a block which is of the same material and contains known dimensions and hole sizes. Here, the technician is calibrating the horizontal sweep on the CRT time base as a multiple of 25 mm, the thickness of the block. There are two types of ultrasonic beam modes usually employed in the testing of welds. These are longitudinal or normal waves and shear or angle waves. The direction of a longitudinal wave is normal to the surface being inspected, and that of a shear wave at an angle. When a change occurs in a material, such as a void caused by a flaw, an acoustic mismatch occurs, and some of the sound energy is reflected back to the ultrasonic probe, converted into an electrical signal, and this is then electronically displayed on the CRT screen. It is usual to investigate a weld using a shear wave probe, as the angle allows the operator to stand off to the side of the weld, avoids the weld buildup, and allows the operator to select a probe angle that will strike the fusion line of the weld preparation at approximately 90 degrees. The fusion line being a likely location for in-weld flaws, such as lack of fusion or trapped inclusions. By reference to the calibration carried out on the test block, the position, length and depth of the flaw in a weld can be analysed from the data given on the CRT screen. Accurate sizing and positioning of flaws is one of the great advantages of non-destructive testing when using ultrasound. This helps with decisions on how to facilitate a weld repair, and also defect sizing plays a critical role in the analysis of structures using fitness for purpose techniques.
Radiographic testing is based on the ability of X-rays and gamma rays to penetrate all materials and thicknesses differentially. An X-ray machine or radioactive isotope is used as a radiation source. This radiation is directed through a part and imprinted upon film stock or an electronic device. Once processed, an image is obtained showing the internal characteristics of the part, with possible imperfections showing up as density changes in the image. Radiographic testing is used to determine the integrity of welds by locating internal defects such as inclusions and porosity, and to gauge the thickness of objects. Radiographic testing also provides permanent film or digital imaging records. Radiographic testing is very costly and difficult to use on complex shapes, though. Defects must be at least 2% of section thickness for detection. Mandatory health precautions are required.
During the remainder of this video, we will concentrate on the other method of non-destructive testing offered by Magnaflux, liquid penetrant inspections. As the name implies, this method uses colored dyes that penetrate into surface cracks to facilitate detection. And, similar to the magnetic particle method, we offer non-fluorescent and fluorescent options. Spot check is the trademark name for Magnaflux visible or red dye penetrant. It is ideal for field inspections of non-porous parts. It is available in liquid or aerosol form. It shows up as vivid red in daylight, and it meets all major military specifications. Penetrant processing requires more steps than magnetic particle testing. All paint, grease, oil, sand, dirt, and scale must be pre-cleaned from the part with a wire brush if needed, to open cracks and allow the dye to penetrate. Next, the part must be thoroughly dried so that the cracks remain unclogged. Then, dye is applied and allowed enough time to penetrate into cracks, after which excess penetrant must be removed. Then developer is applied and the inspection is performed. To show you how the spot check non-fluorescent method works, we will demonstrate the penetrant procedures to inspect this weld. First, SKCS is used to thoroughly pre-clean the part. Second, the part is dried completely. This step is particularly important when using water-based cleaners because water in a crack can prevent proper dye penetration. Third, spot check SKLSP penetrant is either sprayed or brushed onto the part, whichever is more convenient for the area that needs to be covered. After letting the spot check penetrate for about 10 minutes, the fourth step is to remove surface penetrant. First, wipe with a dry cloth. Then, moisten a cloth with an approved cleaner and wipe off excess penetrant. Do not flush the surface with cleaner because this will impair testing sensitivity. A convenient alternative to cloth wipes is our new 1-2-3 cleaner wipes. These durable wipes are pre-packaged and pre-moistened with a water-based, non-flammable cleaner. Fifth, be sure the part is completely dry after you clean it. A cleaner like SKCS dries almost instantly, but 1-2-3 cleaner might require some towel drying. Sixth, shake the aerosol can of SKDS2 developer to assure proper suspension. Hold the can about 10 inches from the part and spray in small sections. Use just enough developer to wet the part thinly and evenly. Applied properly, spot check developer forms a white layer which acts as a blotter to draw penetrant out of the cracks. Too much developer masks indications. Too little of it retards indications. The seventh step is to inspect for cracks. Large cracks appear quickly as vivid red lines. Small cracks show up as dotted lines a few minutes later. If the crack is wide and deep, the red indication will be correspondingly large. Porosity, shrinkage, lack of bond, and leaks will appear as local areas of color. If post-cleaning is desired, wipe off the developer with a dry cloth and then flush with a cleaner. If you encounter penetrant applications that require fluorescent inspections, Magnaflux Zyglo Penetrant is the solution. Zyglo is more sensitive than spot check, so it will locate smaller cracks.